Hi, everybody. It's Miss Rose. Let's learn about our second quadrilateral of the week. It says to draw two parallel line segments that are not congruent. And the hint is the easiest way to do that might be to just make them horizontal. Then it says to draw a transversal that connects the left endpoints. So left endpoint. And then remember that a transversal is just a fancy word for a line that passes through two other lines. So basically, I'm just telling you connect the dots. That's your transversal. All right, right endpoint. Connect the dots. What shape do we get? Well, if those lines are parallel, then this shape that we got is a trapezoid. So the definition of a trapezoid is it has one pair of opposite sides that are parallel. Parallelograms had two pairs of opposite sides that were parallel. So let's write that down also. One pair of opposite sides. I'll just say that are running out of space, parallel. All right, so two pairs of opposite sides parallel, parallelogram. One pair of opposite sides parallel, trapezoid. So we'll be able to use some of the facts that we knew about parallelograms, but not all of them are true. We'll probably just be focusing on properties of parallel lines because that's something that we studied earlier. So problem one says TRAP is a trapezoid with bases RA and TP. It might surprise you that I called those bases because we're used to the word base being like the bottom of something. But for a trapezoid, the bases are the two sides that are parallel. So if you turn your head sideways, it might look a little more like what you picture a trapezoid to look like. The key here with trapezoids is parallel lines give you same side interior angles, which are sups. So we've got these two angles, sups. Then we've got these two angles, sups. So all we're really going to be doing here is a couple of calculations with 180. 180 minus 81 is 99. Done with angle R. 180 minus 132 is 48. Done with angle P. And then what I like to do just to double check, just to make sure that I didn't make any mistakes, is add up all four of those angles. And just like in the kite or any other quadrilateral, all four angles should add up to 360. So I'll put that down too. All four angles add to 360. That's for any four-sided shape. Trapezoids, kites, parallelograms, ones that aren't special, anything. All right, now let's take a look at a very similar problem, but it looks like I didn't give you as much information, and that's because this time the trapezoid is an isosceles trapezoid. And the bases are AB and DC, which mean that the legs are AD and BC. This should remind you when I say legs and when I say isosceles, this should remind you of something that we talked about earlier in this school year, which is isosceles triangles. Picture an isosceles trapezoid is like an isosceles triangle, but with the top chopped off. So remember how isosceles triangles had congruent angles? Well, so do isosceles trapezoids because we're just missing the top of it. So I'm going to start the same way that I did in the last problem. Those are same side interior angles, so they're sups. I'm going to use that magic 180 degree number again that comes up so much in these problems. That gives me a base angle of 50 degrees. And then now I'm going to show you why I mentioned that it's like an isosceles triangle with the top chopped off. We can go base angle 50 degrees, base angle 50 degrees. Those are always congruent in isosceles trapezoids. And then what ends up happening, if you take 180 minus 50, you're going to get back to 130 again. So in isosceles trapezoids, only isosceles. Let's write this down. In isosceles trapezoids, base angles are congruent. And when I say base angles, I mean the lower base angles and the upper base angles. So, I like a buy one, get one free. We've got buy one, get one free for the lower base angles, buy one, get one free for the upper base angles. And then all you had to do was one calculation. All right, speaking of isosceles trapezoids, now let's do something with algebra. So it says AB and DC are the bases again, which means AD and BC must be the legs. And then anytime that I mark two things congruent to each other, and I've got expressions there, that means that you can take those expressions and make them equal to each other. So this should remind you a lot of parallelogram problems that we did, but you might have looked at it and said, wait, I have both pairs of opposite sides. How do I know which ones to pick? The parallel pair, those two are never congruent to each other. It's the other pair, the legs, that you use. All right, I'm going to solve this. 1x, I'm just going to write down x plus 5, and I have my x value. X is 1 plus 5, which is 6. And then after that, I just have to do a whole bunch of plugging back in because it says perimeter. And remember that perimeter means add up all the sides. All right, 4 times 6 is 24. 24 minus 5 is 19. I'm not even going to take the time to substitute back into this side because I know that that will also be 19. 2 times 6 is 12. 12 plus 4 is 16. And then 5 times 6 is 30. 30 minus 3 is 27. So for the perimeter, I'm going to get a 19 and a 19 for the two legs, and then a 16 and a 27 for the two bases. So let me take out my calculator and see what you get. 19, 19, 16, 27 for a total of 81. Notice that I didn't use 360. These are not angle measures. When I talk about a perimeter, I'm saying add up all the sides. Notice I didn't say 81 degrees. We had side lengths. We added them up. It gives us the distance around the shape. All right, now we found some angle measures. We did some algebra. The last thing that I want to do is some practice with coordinates. So we did this a little bit to see whether or not a quadrilateral was a parallelogram. We took a look at slopes. Now we know about kites and trapezoids too. So there's a lot of calculating and checking that we could do. So I'm just going to draw a random quadrilateral. I happen to make it look like a trapezoid. That's just a coincidence. The only reason I like to do that is I like to label the A, B, C, D in the right order so that I can tell what's happening when I do my calculations, because I'm going to be looking for, are there things that are parallel to each other? Are there things that are perpendicular to each other? So first slopes I'm going to find are A, B, and C, D. I'm curious to see if those line segments are parallel or not. So remember, y2 minus y1, x2 minus x1, 6/8. All right, sometimes it helps to simplify that, and sometimes it helps to see it unsimplified. I think I'm going to do both. So 6/8, those are both even, so you can divide them both by 2. You get 3/4. Let's check out if CD has the same slope. So 2 minus 12. 17 minus 17. Oh, this is a weird one. Negative 10 over 0. That's, you might remember from algebra class, that's called an undefined slope. So those two are definitely not parallel to each other. There is actually something else that's true about them that I'll talk about in a minute. So AB and CD not parallel. Let's check AD and BC because that's another pair of opposite sides. Let's see if those are parallel to each other. So see, my picture is just a model. It really has nothing to do with what I'm calculating, but it still is helpful to use as a guide. All right, AD, y2 minus y1. I'm being really careful that I'm actually using the A and the D. X2 minus x1. Negative 6/12. And then again, it might be helpful to look at it unsimplified, and it might be helpful to look at it simplified. So I know that 6/12 is a half. So I'm going to keep that there. And then my last slope that I'm going to find is BC. 12 minus 14. 17 minus 13. Negative 2/4. Okay, first glance that looks unrelated, but then I simplify it and I get -1/2. So those are parallel because they have the same slope. So I have one pair of sides that's parallel, one pair of sides that's not parallel. Does that sound familiar to you? Think for a second about what shape we've recently studied that has that true. And yes, it's the one we just studied. It is a trapezoid. Notice also, these were not the same fraction before I simplified them. So that means they're parallel and not congruent to each other. So that's a sign of a trapezoid as well. The parallel sides are not congruent to each other. So we could either end there and say, we did it, trapezoid. And the reason why is one pair of parallel sides. But for any of you that want to take it one little step further, there's actually something really interesting that happened. From A to B, if you wanted to find the length of that line segment, you could do the Pythagorean theorem. So you could use the slope triangle to find the length. So the fact that we got 6 and 8 for the slope, you could do 6 squared plus 8 squared equals c squared. 6 squared is 36 and 8 squared is 64. So you end up getting 100. And when you take the square root of that, you get 10. So the length of AB is 10. Check out the slope of CD. To get from C to D, you go down 10 over 0. So that also has a length of 10. So actually, as just a bonus challenging extra fact, it's actually an isosceles trapezoid. The two sides that weren't parallel have the same length. There's also one pair of congruent sides, but not the parallel ones. So for this one, my expectation, we haven't studied Pythagorean theorem much yet. It's just come up. It's starting to come up in conversation, so you can tell it's going to come up soon. So I'd be totally happy with trapezoid. I would want you to see AD and BC are parallel and they're not congruent to each other. That makes the shape a trapezoid. The other pair of sides is not parallel. But as an added bonus, a little bit of an extra challenge, it actually happens to be an isosceles trapezoid too. So if you have any follow-up questions on that extra step, please let me know. Otherwise, we'll study it more in a few weeks and it'll make more sense to you then. All right, good luck practicing more with trapezoids. Bye.